Right, now we're going to talk about some syntheses of alkenes. We'll start off with dehydration. If we have a symmetric alcohol, you can see what happens is that the first step will be the OH taking the H+, and then we lose the CH next to the C that had the OH attached. The electrons from the CH bond move in, form the double bond, and kick out the water. But please remember, it's always the CH next to the C that had the OH, not the CH on the C with the OH. If it's a symmetric alcohol, the double bond can form on either side, but it will be the same thing. You can see the alcohol symmetry here, it's got the same thing attached on both sides. If it's an asymmetric alcohol, we can get two double bond products in this instance. One from the double bond forming here, one from the double bond forming here. Fairly easy pattern to see. Just take off the OH and draw a double bond out to any carbon that has a hydrogen on it. These are all expressed as E2 type mechanisms, concerted mechanisms where everything happens at the same time. Not all alcohols can undergo those mechanisms in that way though. What we notice is as follows. We notice that primary alcohols can undergo E2 and only E2. Secondary and tertiary alcohols can undergo E1 or E2. On the previous slide that we just looked at, we saw secondary alcohols undergoing an E2 type process. Let's look at the same thing now as an E1 type process. So here's a secondary alcohol, understanding that secondary or tertiaries can undergo E1, and we're going to show an E1 example on a secondary alcohol. So we use H+, the product is going to be this. And this again is symmetric. So just going through the E1 mechanism, we have the O take the H, form an O plus here, and then we lose the water, forming a positive charge on that carbon. After that, we lose the CH, and it's always the H that's on the C next to the C+. Never the H that's on the C+. That will never happen. Right, and there's our final product. Now notice the E1 went in two steps. We had to get rid of the water first, and then the H plus eliminated to form the double bond right here. In the case of primary, and I'm going to do a primary example of an E2. This will be the product. Let's look at the mechanism. H heads onto the oxygen, and then in a simultaneous fashion we lose the CH that's next to the C that had the OH and the water all at the same time. And that gives us our double bond. Now with the primary it had to happen this way, it had to happen as an E2. If we tried to do it as an E1, what would happen is this. We'd get to the point where we had the H plus attached to the oxygen. We would try to remove the water and we would end up with a positive charge on this end carbon here. That's a primary C+. Primary carbocations are incredibly unstable, so they will not form. In order to avoid the formation of a primary carbocation, it can be done simultaneously, and that's why the E2 mechanism is favored for primary alcohols. The CH will break, leaving the electrons in here, pushing out the water and leaving our double bond compound right here.